Okay, today we're going to talk about cross product. Cross product is referred to as vector product in your textbook, and it's actually a cool right-hand book. So you get your hand. What we have for the whole thing, sorry, I'll start with a basic explanation. We have two vectors, A and B. So this is going to be B and this is going to be A, and they have an angle in between them. If we do what's called A cross B, what we get is the perpendicular vector up here. So this is A cross B. If we wanted to work out the magnitude of A cross B, the magnitude, what we see is from here that it is the area of the parallelogram spanned by the vectors A and B. So the formula we get is A, B sine theta. And that's really cool. So there is this rule which says to find the direction of A and B, A cross B, you curl the fingers of your right hand from the direction of A, so to the direction of B. So your thumb, when you do it, if this is your thumb, it's pointing in the direction of A cross B. And you can see on page 184, this is explained well by pictures in your textbook. However, if what we do is to change the direction or the so if we want a vector which has the same magnitude of A cross B but in the opposite direction, we can see that what we have to do is actually turn it upside down. So it's worth having a look at that in your textbook. Now, because A cross B is like dot product, except we don't have the same versatility. So basically order is really important. So what we know, and it's similar to dot product in the sense, if we have A cross B equals 0, so what we can find is the magnitude means that, if these two are parallel, because A cross B must be parallel, since A cross B equals A, B, and then sine of 0 degrees, because we're saying that they're parallel, when this also has to equal 0 degrees. So if A and B are perpendicular vectors, so what we have is something like this, so A and B, then A cross B has to be perpendicular to that again. So we have A cross B in terms of the magnitude equals A magnitude of B sine 90. Well, what is sine 90? It's just equal to 1, so that's equal to A and B. So three vectors, A, B, and A cross B, form a right-handed system of mutually perpendicular vectors shown in the diagram. So basically this can span our whole plane. Vectors produced in component form. So using these observations about vectors produced of parallel and perpendicular vectors, we can get a range of other things that are important. So for example, I cross I is equal to 0. I cross J is equal to K. And what we can do is form a picture of the relationship between I, J, and K. So then we can write all these out. Well, we have J cross I is equal to, so J cross I equals to minus K. J cross J equals 0. J cross K equals I. And will we have K cross J equals minus I. So you can have a go at finishing those off, and so we're going to start with the next one is K cross K, and then you can check them on page 185 of your textbook. So if a vector produced in a component, if a vector is produced in component form, so we have if A equals A1 plus A2 J plus A3K, this is a formal definition, and B equals B1 I plus B2J plus B3K, then A cross B, now this is when it's kind of like remembering back to matrices and the determinant, equals A2B3 minus A3B2I. So these are looking at more of a determinant approach. A1B3 minus A3B1J plus A1B2 minus A2B1K. Okay, this is a really hard formula to remember, so there is a really easy way. So if we have our vectors A and B here, and we have our components I, J, and K. We can have A1, A2, A3, and we can have B1, B2, and B3. So this is how I write it out. Okay, if we want to work out Y is what I is, you cover the J, and what you can see is we have A2 times B3 minus A3 times B2. Same with J, cover the J, we have A1 times B3 minus A3 times B1. So what it looks like is very similar to the determinant of a 2 by 2 matrix. So that's going back to matrices. So if we had a question, for example, find the vector given A and B and find the unit vector that is perpendicular. So we need to be familiar with the definition of unit vector. So if we had two vectors, A equal to 3i plus 3j plus 8k, and we had another vector which was B equals I minus 3j plus 2k. So what we want to do is so the question is to find the vector product. So it's A cross B is what it's asking us for. So when I do that, I might write it down. So we have A, I, J, and K, and I'll have B, and I'll put the values in. So 3, 3, and 8. 1 minus 3 and 2. This way it helps us get it. So basically I want I, so it's going to be 3 times 2 minus, and I need to put it in brackets because there is a minus here, minus 3 times 8, and that's going to be my I value, plus, well now I want J, so I'm going to cross out J, so I get 3 times 2 minus 8 times 1, and that's my J value, plus my K, so 3 times minus 3 minus 3 times 1 to give me my K value. And what I get out of that is 30i plus 2j minus 12k. Now the second part of the question was to find the magnitude of A cross B. So to do that, what we're going to do is go A cross B, and we're going to find the magnitude. So it is the square root of, well, 30 squared plus 2 squared plus minus 12 squared, or it can just be plus 12, which comes out at 2 root 262. Not very neat. So therefore the unit vector must be 1 over 2 root 262 outside 30i plus 2j minus 12k. And that is the answer to the question. So in your textbook on page 187, there's some more kind of identity questions, and then you're right to go on with all the other questions. This work does keep referring back to the knowledge we've learnt in chapter 5, so you have to have that in mind too.